Good morning, guys. This is KAP, February 3rd, Thursday. Yay, woo, yay. So we're sort of we finished up Croc versus Cop yesterday. Y'all will get those tickets back tomorrow. Some people did very well. Some people had quite a few things that they missed. So that's going to be important when you get those tickets back to make sure you go over them tutorials before y'all's test. Y'all will have a test next week. We'll post a review for that tomorrow. Test and all that stuff. But that yes, it will. Okay. So because the test can have anything leading up to it, so we haven't taken it yet. It's on your calendar, so you can always take a look. See, I don't remember if it's Thursday or Friday or Wednesday, but it's on your calendar. All right, our warm-up today, it says, what is 2 times 2 times 2 times 2 times 2? Your answer, Vivian, what you get?
I got 32.
32, do y'all agree, class?
Yeah.
Yes, okay. With multiplication, like, you can chunk it up. 2 times 2 is?
4.
2 times 2 is?
4.
And then don't forget this guy down here, but I'm still multiplying it all. 4 times 4 is? 16 times 2 is? 32. Awesome job. Okay, that is our warm-up. Go ahead and put that away. Again, my class is going to be turning those in tomorrow, so if you want to warm up, go through all the last 2 weeks of videos and refill them in. If you don't want to lose worry. All right, moving on. Today's lesson, as some of y'all have already seen, we're talking about exponents. Raise your hand if you ever seen an exponent before. Raise your hand if you didn't know what I was talking about, but you're like, yeah. Okay. It's okay. Like some people are hard. So exponents today that's gonna be our topic today. Exponents. Okay, so like in elementary school they taught you like 2 plus 2 plus 2 plus 2 plus 2. That's the same thing as saying 2 times what? 5. Okay, 2 times 5. Like they were like, ain't nobody got time to write out the world's longest addition problem. Let's shorten it, and that's how multiplication became. Do y'all agree with that statement? Sure. Okay, so same thing happened. They were like, well, now what if I want to do 2 times 2 times 2 times 2? Okay, what if I have the world's longest multiplication problem and I'm repeating the same number over 1, 2, 3, 4, 5? They're like, that's too much. That's too extra. Ain't nobody got time for that. So therefore, exponents were created. Okay, what an exponent is it's repeated multiplication. Are we good with that? Okay, exponents are a way that they said, take this really long problem of the same thing over and over and go, whoop, and they just shortened it up, tightened it up, cleaned it up, and said, there's an exponent. And so it was created. All right, so there's different parts of an exponent. This bottom number is called my base. Now what that base tells us is the number that's being repeated. It tells us the factor of the problem, okay? I have a bunch of 2's, my base is a 2. The number up here, the 5, my exponent, tells me how many times I repeat it. So in this problem, how many 2's did I have? 5, and therefore my exponent is 5, because it's 5 times. Okay? The whole thing together is called a power. I don't know why they call it a power, but I always say because it's super powerful, because it makes a really big difference. Okay? And the last and probably the most important to me piece is the way that you say it. Okay? I do not want my 6th graders walking around the room in their house and saying 2, 5. No. Okay? That is not how you read that mathematical expression. There's different ways that you can say it, but please don't write 2, 5. Because what does that mean? Okay? The way that you say it, you can either say 2 to the 5th power. This is our little speech bubble. 2 to the 5th power. Or you can say 2 to the power of 5. Either one is fine. Okay, so everyone, how do you say that?
2 to the power of 5.
2 to the power of 5 or? Nope, not 2, 5. 2 to the 5th power. Very good. Okay, so today we're just going to get comfortable with exponents. It's written differently. It's when the number is written like that up top and smaller, like the exponent. That is called a superscript because it's super cool. I don't know. It says it's up higher. It's called a superscript. And fun fact, in science class, have y'all ever seen like H2O and CO2? That 2, it's lower. It's called a subscript. It's not an exponent, it's low, not high, but it's similar to it. Those cool little things. Okay, so we're just going to break down some examples, just getting comfortable with it. You will have to actively be like, okay, that doesn't mean 2 times 5. It does not equal 10. 2 to the 5th power, we already said, is equal to 32. That was our warm-up. So it's going to take your brain some adjusting. Be active about it. But you'll be fine. You'll get it. I know worries. Okay, so we're going to practice with, given the words, how I would write that in math form. So 3 to the 1st power, my base, my big number is going to be 3, and my exponent would be 1. Okay?
3 times 3.
3 to the 1st power. Now how that's going to look, again, the base tells me what my factor is, so 3, and then the 1 tells me how many times I'm going to use it as a factor. How many times am I using 3 as a factor?
1.
And that's it. Okay, so 3 to the 1st power is going to equal what? It's just 3.
What?
3 to the 1st power, because 3, it's just 3. I'm not multiplying it at all. It's just 3.
The one.
Pause, because you'll see. Just give it a second.
Every number has a name.
Every number naturally has an exponent. Very good observation. Okay, that's right. 3 to the 2nd power. Okay, so this is going to be 3 as my base to the 2nd power up there. Tells me I'm going to have 3 as a factor of how many times? 2 times. So that means it's going to be 3 times 3. Again, it tells me how many times it's a factor, so that means I'm multiplying. Now on this one, 3 to the power of 2 is the same thing as 3 times 3, which class is 9. Are we good with that? Okay. Again, it's going to take an adjustment because I know our brains are used to see 3, 2, that equals 6. It's an adjustment. It's written different, so it means something different. Okay. Once you get practice, you'll get better with it. Okay. 3 to the 3rd power, it's going to be 3 to the power of 3. And someone told me that, I call it expanded form because they take the shirts out and expand it. That would be class 3 times 3. Very good. And Arthur said that equals 27. Okay. And last but not least, 3 to the 4th would be, okay, chunk it. 3 times 3 is?
9.
3 times 3 is?
9.
9 times 9 is?
1.
81. All good with that?
Yeah.
Okay, now I skipped over 2 little things, the squared and the cubed. Okay, have y'all heard like 4 squared before?
Yeah.
And 26 cubed before?
Yeah.
Okay, especially in area from elementary school, you would say units squared. Well, when you did like your area, it was always like length times width, right? It was length times width equals like whatever units squared, because you're doing 2 things times each other. So whenever you hear something to, if I said like 16 squared, that would be 16 to the power of 2. With volume, it was length times width times height, so it's 3 factors. So whenever you hear something cubed, that means to the power of 2. Now, a cute little way that I've learned, a square. So think of dimensions, 2D shapes, 3D shapes. There were 4D shapes and stuff like that. A square is how many dimensions? 2D, so squared to the power of 2. A cube is 3D. So cube, it's not the best, but it's not the worst. It's something to go off of. Are we good with that? Okay, so just a little review of vocabulary. If I'm talking about a number expressed using exponents, the whole thing, if I said 5 to the power of 3, that whole thing is called a power. Very good. The whole thing is called a power. The number used as the factor, so if I'm looking at 5 to the 3, which one is used as the factor? The big number or the small number? The big number, that's called my base. And then how many times the base is used as a factor? Big or little? Little, that is called my exponent. Very good. Okay, the next 2 we haven't talked about yet, so we're going to take a little second. Numbers that are square of whole numbers, these are called perfect squares. Perfect squares. So just sort of kind of how you can like classify numbers as like integers, rational numbers, whole numbers, all that kind of stuff. Y'all remember that? The little funnel thing. You can say a number is a perfect square. It's like a describing word. So certain numbers are perfect squares. So I will list them out to you. So the numbers, okay, if I did 1 squared, 2 squared, 3 squared, 4 squared, their answers are perfect squares. So if I did 1 squared, that's the same thing as 1 times 1. That would equal, sorry. So 2 to the power of 2 is the same thing as 2 times 2, which is equal to 4. Okay, again, don't want to trick you. 3 squared is the same as 3 times 3, which is 5. And then 4 squared is 4 times 4, which is 16. So these numbers down here, those are perfect squares. Perfect squares. This isn't super important, but it's just a little fun fact. This will come into play next year in 7th grade KAP a lot. Okay? So just getting you like, okay, that's a number. Yes.
Where did the photo go?
It fell down, but we're fine. Okay? Let's stay with the lesson. The last little thing is expressions with the same value. These are equivalent expressions. Equivalent expressions. Now, the reason why we're talking about this is because exponents are an equivalent expression to the repeated multiplication. Give me a second. I'll let y'all copy that down and I'll show you what I mean. Okay, so what I mean by that, they're equivalent expressions. 2 to the 5th power is equal to, is the same thing as 2 times 2 times 2 times 2 times 2. Okay, those are equivalent expressions that they give you the same answer, just different ways of writing it. Are we good with that? Okay, we're going to be doing a lot with equivalent expressions here in a few weeks, so just getting familiar with that term. They always are equal. Okay, so now we're just going to practice. We're not solving anything yet. We're just practicing writing things as exponents. I'm also going to have us practice saying things, because the only way to get better is to practice it. Okay, this isn't too crazy. So I'm going to do the first one, and then y'all are going to do the rest of them. Okay, number 1, I see 6 times 6 times 6 times 6. So another way I could write that, my factor is 6, and I'm going to do it to the power of 4. 6 to the 4th power, or 6 to the power of 4. Are y'all good with that? Okay, do the rest of them. Just write them as exponents. You don't have to solve. Pause and play when you're ready. All right, so number 2, 4 times 4 times 4. Tell me how to write it and hopefully how to say it. Amen.
6 to the power of 4.
Well, that's number 1. I did that one with you. Number 2,
4 to the power of 3.
4 to the power of 3. Do y'all agree? 4 to the power of 3, or I could say,
4 to the power.
awesome job. Will, number 3. 7 to the power of 4, or class? 7 to the 4th power. Thank you, Will, again. I guess. Michaela, for number 4. 9 to the 7th. 1, 2, 3, 4, 5, 6, 7. Do y'all agree? Yes. Okay, spicy Lionel, put a spicy number in there. Oh my gosh. Abe.
I've got 5 to the power of 3.
Not 5 to the power of 3. 0.5, but let's write it as a fraction because it is a fraction. 1/2 to the power of 3. Now, for this one, I can almost guarantee you, you're going to have to fix something on it. On this one, you actually have to put it in parentheses. You have to. You have to put 1/2 in parentheses, and I'm going to tell you why. Okay? So the reason is, and I'm going to go on a little bit of a tangent. Do y'all remember like order of operations from elementary school, the PIMDOS thing? Okay? If you remember, exponents comes before like multiplication, division, anything like that. If you write just 1/2 cubed, that third power only applies to the 1. Okay? And so that would be 1 times 1 times 1, which is equal to
3.
no, 1 times 1 times 1. It would just be 1/2, which is not what is being shown here. What's being shown here is 1/2 times 1/2 times 1/2. Let's see what would that equal. We're not solving all of them, but just this one for this case. fractions, we just multiply across. We already said that 1 times 1 times 1 would give me 1. But the bottom, the denominator, 2 times 2 times 2, it should equal 1/8. So because of that, because of the rules of order of operations, I have to put it in parentheses because it's saying I want all of it to be multiplied. Does that make sense? Okay, so you have to put parentheses when it's a fraction.
So it's like if you want one sheet. No, it's like you don't want one sheet, you want the entire thing.
Yeah, love it. Great. All right, moving on. I just wanted to make sure we talked about that. Carrington number 6. Very good. 0.8 to the power of 5. With decimals, you don't have to put them in parentheses. I sometimes will. Sometimes it just parentheses make me feel homely. They're like a nice warm hug. Okay, it doesn't hurt anyone. You can put parentheses, but this one it doesn't matter. Okay. 7. What would that be, Maria?
3/4 to the power of 4.
Very good. All right, here we go. 3/4 to the power of 2. Class, why you have to have parentheses? Yes, I do. Okay, so if you didn't do it, again, you didn't know. So go ahead and add them.
Fractions always be parentheses.
Correct is what I just mentioned. And then Tanner, you want to take your? I know I called you on the last one. The last one's the spicy one. You want to take a guess? Come on, try it out. It's okay. Come on. What do you think? What do you see? What's tripping you up? 2 different numbers. Okay, chunk it. How many 5s do you see? So how would I write that? Awesome. Very good. And what else do you see? And very good. And you just put a little dot in the middle. Okay? I know. I'll put them on the spot.
You really like putting dots for those at the zoo.
I do. I do. Are we good with that? We see we're like, oh, yeah, that makes sense. Okay? Next page. Next page. Now we're going to do the opposite thing, and we are actually going to solve. So, when we are given an exponent, if it says to write as a power, write each power as a product is the same factor, I like to think of this as just like expanded form. I'm taking that exponent and I'm expanding it out. Okay, so if I have 5 to the power of 2, or what's the spicy way of saying 5 to the power of 2? What's the fancy bougie way?
5 to the power of
5 squared. Very good. Okay, 5 squared is the same thing as
5 times 5.
5 times 5. Very good. Okay, so we're going to write it in an expanded form, and it says determine the value. Determine the value is just a fancy way of saying
Find the answer.
solve. Okay, 5 times 5 is 25. Okay, let's just start with the expanded form of the rest of them. Okay, start with that. I'll give you about 45 seconds. Pause and play when you're ready to look at the expanded form. All right, that is the expanded form of all of them. Now, because again, I want to make sure you wrote it out right before you solve all of them, because that would be tragic. Thank you so much. Okay, just a quick review before we do multiply. Okay, so like on number 2, we have to multiply by decimals. We haven't done that in a hot second, so let's just review. I'm going to chunk it, okay? 1.5 times 1.5. You multiply like normal, so let's do that. 5 by 5 is 25. 1 by 5 plus 2. 1 by 5 plus 2. 7. Thank you. Placeholder. 5 by 1. 1 by 1. Add that. And then what's left? Add the decimal where? How many numbers are behind my decimals? 2. So I need to move it to 1, 2. Getting it up right there. Do y'all agree with that statement? Okay. So that gives me 2.25, but I still need to multiply by this guy. Y'all get to do that. We already reviewed how to multiply by fractions as well. So I'll give y'all like a minute and a half to solve the rest of these. Ready, set, go, and then I'll play when you're ready to go. Here we go. So when you ended up multiplying that times 1.5, what did y'all get as your answer? Okay, let's raise a hand. Thank you so much for the answer. especially while we're recording. What do you gonna get? Aurelian, what did you get? 3.375. I know that whole back table got that same answer. Okay? 1/2 times 1/2 times 1/2. We already solved that. It's equal to 1/8. 10 to the power of 5 is the same thing as. Okay, a really quick, easy way to check. It tells you the number of zeros that will be in it. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Slap the number on top. Okay, so that would be 100,000. It's a beautiful. It only works with 10. Only works with 10, but it's beautiful. 2.1 times 2.1. We got. Thank you. 4.41. And then 1/4 times 1/4 is very awesome. Okay, I'm going to do one word problem with you, and then y'all are good to go. The zoo has an aquarium that holds around 7 to the 4th gallons of water. How many gallons of water does the aquarium hold? AKA, solve it. So let's take that 7 to the 4th and write it in expanded form. That would be the same thing as 7 times.
7 times 7 times 7 times 7.
Okay, 4 times. Okay, chunk it. 7 times 7.
49.
49 is an example of a perfect square. What's the other 7 times 7 going to equal? Okay, and then multiply those. Take a second, pause and play when you're ready. 49 times 49 is.
2,401.
Thank you. 2,400. 2,041 or 401. Y'all agree?
Sure.
One of my favorite people.
What?
Alrighty. Oh, there is gonna be. Let's do this real quick. Sorry. Next page. We're gonna skip around, and then I will set you free. I promise. After this, pinky promise. Complain some more. Why don't we? Alrighty. Last little bit is filling in this table because what do we notice right here? 2 to the 0 power.
It's 1.
We don't know what it is. Okay, so here we go. Let's say we didn't know. Let's say Michael didn't shout it out to us, but at least he's looking at how close it is, so we appreciate it. Anyways, it is on my invisible map, but let's discover why it's there. Okay, so let's sort of notice some patterns. So we said that 2 to the 4th, 2 times 2 times 2 times 2. Do we agree that's going to be 16? That's 4, 4. Do we agree with that statement? Yes, okay. 2 to the 3rd, it's 1 less power. Okay, so it's 1 less term. What could we say is happening from 16 to 8? They are dividing by 2. And that makes sense because I'm multiplying 1 less, right? Okay, same pattern happening, dividing by 2. If we had to guess, 4 divided by 2 would be 2. And we agree. We said 2 to the 1st. That was on our warm-up for the first page of notes. And by that rule, let's figure it out. 2 divided by 2 would give me 1. No. 2 divided by 2 would give me 1. Okay? 2 to the 0 power is 1. Oh, yes. I'm sorry? We're going to get there, but let's focus on today. So, I sort of want to discover if that's a pattern, if that's a rule or not. Okay? So, if I go from 256 to 64, take a guess, they're going to be dividing by 4, because it's 1 less multiplication of 4. 64 to 16, divide by 4. If I keep dividing by 4, I would get 4 here, and then one more time, I would get 1. Okay? There is going to be a pattern. Divide by 10. Divide by 10. I'm dividing by whatever my base is. That would give me 10, and that would give me 1. Okay? There is a rule, and so we are going to write the rule. If any number to the power of 0 will always, not sometimes, always be what? Be 1. Okay? I'm going to show you another reason why. Ms. Idle has secretly been lying to you this whole lesson. And I'm I'm fessing up right now on recording. In YouTube, I'm fessing up. Okay? Let me go show you where I lied to you. On this very first page, very first problem, I lied to you the whole time. Okay? Uh-oh. So pay attention. When we wrote out the factors, y'all ready? It's secretly times 1. Oh, I'm sorry. Times 1. Times 1. Times 1. Okay? Does that change the value of anything? No. So I'm like, what's the point? Okay? But the only time that comes into play is when you have something to the 0 power. If I did 3 to the 0 power, again, there's always that implied 1, but how many times am I going to use 3 as a factor? No times. I'm not gonna write times 0 because 0 is not even a part of the conversation. I'm multiplying, there's nothing to multiply by. So that is why it's actually gonna be 1. Okay? Because thank you. Okay? When we do exponents, when we do powers, there's actually a secretly implied times 1, but it doesn't change anything. The only time it actually is important is when it's to the 0 power. So any number to the power of 0 will always equal 1. Nope. Let's try one more time. Anything to the power of 0 will always equal 1 because there's just a hidden 1 there. All right. That is today's lesson. Let's work on the rest of the partner practice that we sort of skipped over. And then your homework will be on that back page. You can try to do this tonight. Thank you. Thank you.